Okay, I think we're back. Hope everyone enjoyed lunch. So we're back for a full afternoon of presentations. We have kind of a long afternoon, mainly because I found out that Jordan Sissel was going to be here, and so I squeezed him onto the end of the agenda. So you can blame me for the long day. All my fault. Up next, we have Jos, who's going to talk about how to measure everything. Absolutely everything.
All right, with only a small delay, let's get started. So first of all, if you have any questions, just raise your hand. I'll do my best to take them. It's kind of a wide room, so you might want to just like wave them around a little bit or just even shout. When the presentations are done, I'll be uploading the slides to SlideShare, so don't take too furious notes. They'll be all available for you. And I'll announce them on Twitter too, so you'll have a link. A lot of the slides, if you look at the bottom right, there will be a little bit of a link there in dark gray. Whenever I claim numbers or point at code, you can trust that the link is there and that they're real, and you can go and verify later in your own time that I didn't lie to you. All right, so let's get started. Before I did what I do now, I used to work for a company called the RIPE NCC. Who's ever gotten an IP address here assigned to them? Excellent, that's what we did. And anybody here ever try to get a /8 assigned to them? Really, just me? Yeah, that's when we say no. So it's anywhere between 1 is fine, and then, you know, like 255th of the internet is not fine. And then I went to Canonical. Any Ubuntu users here? Cool. I saw at least one Red Hat user, or at least one person with a red hat. There you go. Red Hat user? I'm going to assume you're an Ubuntu user and just don't even confirm or deny that. Ah, damn it. So I've got one convert in. OK, so I was the engineering manager for Ubuntu Server, and we did 10.04 and 10.10. And 10.04 was the first big launch for EC2 for the Amazon version there. And that was really, really interesting. I think it's still the best one, especially for EC2. It's definitely the most popular one there. And if you run Java on Ubuntu, I'm sorry. It's I know, like we have a couple hundred lines of Puppet code, just fix all the things that we couldn't get out before lunchtime. And so about 4 years ago, I joined a company called Krux. And the way we talk about it, it's kind of like Google Analytics for audience rather than traffic, or that thing that Netflix does to figure out what you want to watch, and that thing that Amazon does to figure out what you want to buy. We do that for everybody else. So any type of content that you want to consume online, we help you find that. And we do this for most of the big publishers. Around here, you probably know Axel Springer, a big local publisher. I've seen nodding heads there. New York Times ring a bell, too? It's paper over in the States. They do quite well. Anyway, so it turns out that a lot of these websites have exactly these needs. They want to give you articles that you like or advertising you're interested in, find the authors that do pretty well that they should write more on, stuff like that. And that means that we got a lot of the top 50, maybe even top 100 digital properties using our stuff. In Europe specifically, because we have a very strong focus on data privacy, like we don't sell this data. This is between the customer, the end user, you, and the website operator, say New York Times or Axel Springer. And we just make all these analytics possible. And because data regulation is so stringent in the EU, and especially in Germany, it was really, really easy for us to do this for them. So it comes with a bit of a downside, or an upside for me, because I'm an operator. I think this is fun, but it means we get a lot of traffic. For every page view that these guys get, we get one too. And we're on the critical path of their delivery, because we do content recommendation and so on. So outages would be really, really bad. I always like to put this in a little bit of perspective when I say a lot of traffic and stuff. It's a little bit of an apples and oranges comparison. Twitter does a bit more with their tweets than we do with our incoming data, but Twitter gets on average about 9,000 tweets a second. I think their record is 33,000 last New Year's, when all the Japanese tweeted Happy New Year at each other. Apparently we didn't beat it this year, which I guess it's a passing fad in Japan. But that peak is our daily average. So on average, we do 33,000 new data points every second. And on external requests, we do about 70 to 90,000 a second on average. So in terms of reach, we see about 1.2 billion users, which is a little bit more than double than Wikipedia sees. So it's a fair amount of stuff. It's about a 1.5 billion key store and about 25 terabytes of raw data that we process every day. So that's all well and good, but when you process this much data, and for this many users, and for this many clients, any small decision you make or any small change you make can have a huge impact. And when it's a change in service performance, we'll definitely want to know. And if we want to make a design decision, we want that to be really well informed. And if it's a cost-benefit analysis, we of course want to slice and dice it from every possible angle. And to that end, we collect, on average, 1 million unique metrics every second from our production environment. So I want to talk to you a little bit about how you can set up a system that also captures 1 million metrics a second, and how you can make that useful and actionable. I mean, it's one thing to collect them all, but if you can't do anything with them, it's kind of useless. There will be a bit in here about how to visualize that data. Most effective visualizations probably depend on the problem space you're in, the domain you're in, personal taste. I'll link a few, but there are so many front ends for the tools I'm about to show you that you can really just pick whatever suits your fancy. And the same goes for monitoring systems. I'm assuming most companies already have a monitoring system. Actually, does anybody here not have a monitoring system in their company? Just show me with a very small finger. It's like 2 people. That's good. But even so, I'm pretty sure the higher order bit for your monitoring system is not how many metrics it can capture, but some other business value that comes out of it. So again, I'll show you some stuff that we use and we like, but mix and match the tools will accommodate. And even though I'm not talking too much about visualization, don't underestimate it. I mean, computers can do a lot for you, but the human brain is so good at patterns and shapes. So just looking at the data points when something is wrong is really not good enough. If you have a good visualization, it'll help you with things like, well, does it always behave like this? What does your normal look like, and how does it look like right now? How is that different? What changed recently versus some time ago? When you look now, it's wrong. Well, what changed when and why? Was it a code deploy? Did machines drop off? Was there a network partition? And what kind of things correlate very strongly? Is disk I/O the symptom or the cause of the problem? And conversely, what's the leading indicator? It could be that disk I/O rising means you're going to have a problem in 10 minutes. Those are really good things to know. And in some cases, the shape is just as important or maybe even more important than the data itself. So we have this graph that shows us requests per second. And there was this really interesting shape that happened one morning where the requests per second went up by 30, 40% over 20 minutes, kind of like this, and then dropped off gradually like that. I'm like, okay, so what happened? Did something break? Did somebody put in a cache buster? Did sales sell something again to like a top 5 website and forgot to tell us? Like, these are all options, right? And we looked at it and it's like, no, it's all fine. And we found it's a news event. This is the shape of a news event around the world. We see enough traffic that I can tell you exactly how long it takes before the world knows about the news. When Kate has a baby or when somebody bombs Boston. So now in the morning when we do our stand-up meetings next to these screens, and we see the shape like, oh, I should probably go read the news. Looks like something interesting is going on in the world. And so I told this story to a friend of mine who works in Google's SRE team, and he's like, oh, yeah, we've got a shape like that too. And it's basically where the request per second spikes dramatically, but the cache hit ratio stays the same, meaning that a lot of people are looking for one specific thing all at the same time. And the query is Facebook down? And so apparently they can now see, just by the shape of that graph, how long Facebook is down for. It used to be, let's say, this much, and they've gotten better over time, but that's their shape. So they used to think, oh my God, something bad's going on. It's like, no, Facebook appears to be down. So shapes are incredibly important, and visualization really, really matters. Most teams use the metrics just to diagnose outages or troubleshoot their systems. And even though there are definitely valuable tools for that, there's so much more you can do. You can start to understand your trends over time. You can do capacity planning, performance tuning, A/B tests. Very important for us, cost predictions and optimizations. You can learn about the new normal when you do code deploys and so on, like how does it affect users. You can build your design decisions based on that. And not in the very least, all your KPIs and business metrics should probably be in here as well. And you should include everyone. It's not just for operators to have a bunch of metrics in there. Your developers can write better code if they know how their stuff behaves. Your teams can make better purchasing decisions if they know the bang for their buck. You can make better product decisions. Your salespeople can prove how your tech works. The amount of times that I send graphs over to potential clients that show us error rates, latencies, that kind of stuff, it's invaluable. And it lets your support team quantify problems. When a client calls and says, the site is acting weird and is sometimes slow, That's a horrible bug report, but your metrics can probably tell you what's going on and help you diagnose that problem. So why do I harp on about metrics? This is our revenue versus cost line. I had to take off the numbers for legal reasons and stuff, but the shape holds. By using that data that I'm about to tell you about, we were able to grow 10x, 10 times the size of the company, while keeping roughly the same cost profile, because we figured out what to optimize, where the waste was, and where we weren't getting the best bang for our buck. And these are these are costs across the board. It's hosting, storage, processing, but also CDN, DNS. We optimize everything as far as we can. And our revenue tracks the amount of unique users and impressions we get. So that means that our entire infrastructure is doing 10 times as much work as well, but for the same price point. And using this data to make these decisions, we avoided at least one round of funding. And if you're a venture-funded company, you know how important that is. That's a lot of cash in our pocket. All right, so what's the secret sauce? What did we do to build this? And really, we just did one thing. We made it really, really easy to use. That's it. You can't look at metrics that you don't have, and if adding metrics is hard, it won't get done. It gets pushed to the end of development cycle, people push it off, it becomes a nice to have, and now you have this legacy code that you can't introspect. Now, of course, there's a bunch of other characteristics that would be really nice to have, especially at scale. So a scalable, cost-effective solution, something that's pretty easy to operate, easy to integrate with, because things spit out stuff in one format and you need to capture it in another. Easy to interrogate. You want to be able to ask it any question you have, not just questions that it tells you can ask. And it should be really configurable and flexible on its inputs. So I'll try to cover all these bits as we go through. But let's start by what we want to see. From all the metrics that you'll be collecting, most of them you'll only need when you're making a specific decision or when you're trying to answer a specific question. And so then the question is, well, what is it that you should always visualize? What is the one thing that you should probably show on your dashboards and so on? And the most important part, in my opinion, is to have a high-level overview of whatever your KPIs are. And then, in turn, you can drill down as far as you want when those KPIs aren't aligning with what you want them to be. They'll be different from company to company, and despite our million metrics, ours are really straightforward. Error rates and latency. That's all that really matters. Because we care only about customers having the answers that they want correctly and quickly. Everything else is secondary. So as an example, I want to show you how we build those dashboards and kind of how we think about that. So let's start with this, request rates and error rates. We run dozens of different services, and all of them roughly have the same characteristics, right? Because they serve a request in a certain amount of time. So the first one we'll want to see is what the request rate is and what the error rate is. And I just picked a random one here. We have many machines that run this particular service, so we aggregate across. And this is a 2-day window. It shows roughly the same shape twice, which is healthy, because if they would be vastly different, probably something changed. And there's nearly no errors, which is, I'm glad I picked this service to show you. All right. Just as important as that is the response times from the cluster. Because we run many machines with this service, it's really important to track the worst 95th and the worst 99th% response times. If you have many machines and 2 of them are misbehaving, the odds are that the rest of them will mask the 2 misbehaving ones in response time. So if you take the average 95th response time, it looks pretty good. You want the worst 95th. This is the thing that affects a small group of your people, but that's how badly it affects them. And remember, we see over 1 billion users, so if 1% of our users are affected, that's actually a large amount of people. The other thing is that you should probably track the 95th and the 99th rather than the average response time. The average response time only captures half of your people. So half of them might be having a really bad experience and you wouldn't know. So 95th and 99th. The reason that we pick 2 and not just 1 is because the way that they track tell you a story as well. If the 95th is pretty consistent and the 99th spikes all over the place, you probably have some erratic services or some erratic behavior. If they both go up at the same time, it's probably an underlying problem, like a database being slow, a network being partitioned, CPUs being saturated, like everything's affected across the board. All right. One of the reasons that your latencies or error rates might go up is because something changed in your environment. And there are 2 really common things that you probably do all the time that I'm pretty confident most people aren't tracking right now. And that's when you deploy code and when you do some sort of processing job that really hits the databases. In our case, we run a lot of MapReduce because we process this data, and whenever that happens, we might be flushing disk caches on our databases. So we track those events, vertical lines. One for deploys, which is the brown lines you can see, and the pink ones is when MapReduce starts. So it's a pretty good indicator that when latency shoots up or something changes right after deploy, probably somebody broke something. And as you can see on the right-hand side, there's two brown lines right next to each other. I'm sure our devs will tell us that there were 2 quick feature releases, but my gut tells me bug fix. And now I know, right? And probably if I zoom in between the two, I'll see a higher error rate or something like that. All right, and then the last one, as you're making your service, you'll probably have a fair idea of what the capacity is or what the ideal capacity is of that particular service. You probably benchmarked it. Now, in our case, we set the expected capacity as a horizontal line, and we set that to 2/3 of the max throughput. That gives us the flexibility when a code deploy actually increases latency or reduces the amount of requests per second it can take. Also when nodes start failing, so we have a little bit of a buffer. And to help us visualize that, we draw this horizontal line, and we multiply it by 2/3 times the amount of nodes that we have in the cluster, which we all get dynamically, and that's just the capacity. And so it kind of looks like this. And this is a health dashboard that we have for every service that we run. There's nothing special about it. They all look like this. They have different names, but in all cases, it's latency, it's request and error rates, capacity, important events. And so in one view, I can see what's going on. All right. So why would we bother to collect 1 million metrics if this is all we're looking at? That's because these metrics can help you make really good decisions to diagnose issues and to correlate events. So any system that we're about to set up should really encourage the collection of metrics and make it easy to do so, not just let you capture that. So when your app response time spikes, it might be a deploy, might be a slow disk, saturated network, your machine might be swapping, might be CPU contention, could be any number of things. But unless you're already capturing those metrics, you won't know. And if you have to instrument the application when the problem happens, you're going to, first of all, lose a bunch of time instrumenting. You are possibly introducing new bugs or slowness that now change the metrics you're getting in the first place. So now you're comparing apples and oranges, and you won't have any data from before the event. So if the number comes in at 42 now, well, is that higher, lower, the same? How much is it different? You wouldn't know. You didn't have the previous number. So capture it up front and just capture everything. All right. So given that we want to collect as much of information as possible, what's the best infrastructure to get it done? And ideally in an easy, low-cost, scalable kind of way. So we like the combination of statsd, collectd, and Graphite. And here's roughly how it works. On every individual node, we run a statsd client and a collectd client. Collectd gathers the system data and runs some monitoring plugins, but that's a different story. And when it collects that data, it sends the data points to statsd. Any applications that run on the same machine also send their data points to statsd. Statsd then gathers the statistics, does a bit of basic math, and then sends it off to Graphite for storage and interaction. And so I like to dive into all of these components separately and kind of see how we set them up in the most efficient way. Okay, it's not me. Okay, who has never heard of collectd before? Awesome. See, I've been doing this at every presentation, and you guys are like the most informed crowd. It was like one where the 80% of people were like, I have no idea what collectd is. So I'll go through it quickly. collectd is a systems metrics and monitoring tool. It's a daemon that runs on your system, and every n seconds, you can figure out how often n is, it runs a bunch of plugins. It comes with a whole bunch of standard plugins, and they tend to measure system stuff like disk, CPU, network, and so on. But you can also add your own plugins to it. So they could be for your own applications or for services that you run that have metrics but don't have metrics in a way that you would like them yet. For example, Redis and Cassandra have tons of metrics they expose if you connect to their admin port and you ask for them. But then you have to put them in a system that you can actually act on them. So you would write a plugin, take all the metrics, and put them into collectd, which then would send them off to statsd. The nice part of collectd is also that when those metrics come in, it can send a state. So it could say, disk usage now is at 95%. That's not okay. And then you can have a notification plugin that sends it off to your monitoring system. It says, I just found 95%. I don't think that's okay. All right. statsd. Who's never heard of statsd before? Awesome crowd. Okay, so statsd is the core of our metrics collecting setup. It's a tiny little Node.js daemon. It's come out of Flickr. It's gotten a lot of adoption in Etsy, and basically any cool little startup that decided to use their tech in the last 3 years. It'll accept a metric and a value. It does some really basic math and then sends it on to its backend. The backend is by default Graphite, but there's all kinds of plugins so you can send it to basic, any metrics or any monitoring system that you have. Metric types are counters, gauges, timers. It's really straightforward. Now, here's why we run it on localhost. The daemon takes a UDP message and then sends a TCP message onto its backend, or HTTP, whatever the backend wants. TCP and HTTP can be blocking, can be highly latent. UDP, however, is fire and forget. The downside of fire and forget is I don't know if it arrived. However, on localhost, UDP is basically guaranteed delivery. Or I should rephrase it as, if you are not getting localhost UDP packets, you have different and bigger problems than not getting localhost UDP packets. Another benefit is that now the stats collection is a function of the node. So I can horizontally scale my nodes, and my stats collection will be able to keep up. I don't have like one big bottleneck of stats collection where some really noisy or big cluster comes in and overwhelms it or something else. So statsd on localhost. To avoid insanity, pick a naming scheme and stick to it. There's a handful of reasons for that. One, it makes exploring in Graphite much easier, and I'll show you why in a moment. Two, it makes creating graphs a lot easier. Same naming scheme means that it's really easy to go and explore and go like, oh, this is just a service that I gave a different name. This is the foo service, this is the bar service, but they all have stats that look in the same way. So if I'm a developer that usually works on foo, I work on bar, I know where to look, I know what to do. Same for the operators. It also makes automated rollups much easier, and I'll show you that in a moment in Graphite. So here's what we picked, and you can totally copy this or invent your own. That doesn't really matter. The important part is stay consistent. Pick one, stick to it. So here's what we do. We separate the stats by the environment they're in. Production, staging, dev, prototype, whatever. That's the first little bit. The second bit is the cluster name. And our cluster names are something like API Ashburn, www Dublin. So it's a cluster in a location. This helps with very easy drill downs and if needed metric cleanups. So I can see how the www cluster in Dublin is behaving quite easily by just looking at everything underneath that, and I don't get it conflated with anything else. Then we suffix it with the host name it came from. That way, one, you avoid duplicate metric names coming in. You know, if two hosts both send the foo metric, well, where did it come from and who said 42 and who said 21? It also allows for host-specific stats, so I can see how this particular host is doing, and it also makes easier aggregator setup, which again I will show you in a moment. We set the prefix, so the stats.environment.cluster name, and the suffix as part of the statsd configuration, which I'll show you in a moment. So the other benefit of that is that developers don't have to think about it. They just have to name their app and then send metrics, and the rest is taken care of it. All right. So this is the basic statsd configuration that you should have. There's many more bells and whistles, and the documentation is linked from the right bottom, so if you want to read through it, it has something like 200 options. These are the ones that really matter. Let's assume that you use Graphite as your backend, and then you should definitely start there. We set the prefix like we just discussed, stats.environment.cluster name. Then the suffix is a little bit of JavaScript that just gets the local host name and puts it in there. We make it JavaScript because then I don't have to code the local host name for every host. I'm lazy. Legacy namespace equals false. statsd's been around for a little while, and they used to have a namespace that was less awesome, let's just call it that. But the default is still to use the less awesome namespace, so you should just set this to false and get the new awesome namespace. The percent threshold is the upper so manyth percentile. So when I was showing you 95th and 99th, this is where you tell it to compute the 95th and 99th. There's some folks also who do the lower 10 to see their optimistic response times. Up to you, add it in or not. And then the important one is delete idle stats equals true. statsd will send a 0 for every stat it's seen once and then never seen again, so you have consistent metric points. But with delete idle stats equals true, it won't send that anymore, which means you'll keep your traffic down. It also means that it's very easy now to see what your idle metrics are and just throw them away. So if a metric hasn't been updated in a month, probably the developers didn't care anymore, just throw them away, or whatever your rule is to do this. All right. Graphite. Who's using Graphite right now? Nice, excellent. All right, so that's where we send all of our metrics right now. All the graphs you've seen so far come directly from Graphite, and I think the people who use Graphite will probably be bored with how vanilla our setup is. These are all the defaults. It uses a thing called WhisperDB to store its metric, which is very, very similar to RRD graph, if you know about that. Basically, it means that it's a round-robin database, and you have a fixed size for every metric, and your metrics will never grow beyond that size. So from day one, it'll be a certain file size, and it'll never grow. So it's very easy to do capacity planning for this. It comes with a built-in query composer, built-in graph creator, but it also returns the data as JSON if you want. So if you want to build your own tools on top of it or on your own monitoring on top of that, you can just ask it for the raw data rather than the graph, and you go from there. Oh, and it's open source. Free as in beer, which is pretty awesome too. So one major constraint that you should be aware of in Graphite is that beyond very powerful wildcards, there's no real search mechanism in Graphite. So naming scheme is now super important. I heard that Jordan's around here. Jordan, are you actually in the room? Not yet. OK, like me, he's showing up late. Good to know. He works for a company called Elasticsearch, and I'm really keen to see what they will do with Graphite meets Elasticsearch, because it could use some help. All right, so how would you set up your Graphite to do what we do? First of all, we only run one Graphite instance per data center. This is to minimize the risk of network failure between the localhost statsd and the Graphite in the same data center. If we go cross-Atlantic or so on, we're much more likely to lose data than in the same data center. You could run a cluster of 2 or more if you wanted data duplication on your live systems. We chose to aggressively back up instead, and that's for 2 reasons. One is we actually have a lot of metrics, which means double the disk capacity is actually quite expensive. And our worst case scenario is that we restore pretty quickly and we have a gap in metrics. Metrics are not on the critical path of our client deliverables, and we know that we can get it back in about 15 minutes. So our absolute worst case scenario is a gap of 15 minutes in metrics, and we choose to accept that. If that's not acceptable to you, run 2 or 3 and copy the data over. Every Graphite also has its own MySQL and Memcache. MySQL is for stored stuff like queries, dashboards, user accounts, if you so care. And Memcache is for caching metrics requests, which is particularly important if you build these dashboards like I did, because we update them every 5 minutes. And it's kind of silly to get a week's worth of metrics every time for just the 5 minutes of new ones. So it'll put the old ones in Memcache and then just find the 5 new ones. You should pick one Graphite to be your web UI. And contrary to what you would think, it should not be the Graphite that is physically closest to you. You should pick the one that has the most data points on it. In our case, that's Ashburn, because it turns out that because all nodes will have some metrics on them, they will stream those metrics to the node that you made the request to, and that node will aggregate them and give you the result. And the metric streaming is much more costly than the latency between you and the node. So even if you have that node sitting in Australia, pick that one as your web UI, because you'll get metrics faster. All right, let me talk to you about some of the key things you should do for your Graphite setup. 1, data retention. In Graphite, you can set up data retention in all kinds of modularities. You can get really, really detailed. You can use very complicated patterns. You can even use regular expressions if you want to. We found that the easiest way to do it is to do this. For all the stats that we have, .star, keep them at a 10-second granularity for 6 hours, which is identical to the statsd flush interval. So if you set the flush interval for statsd lower, you should set this one lower and vice versa. Keep them at 60-second granularity for 15 days, and then 600 seconds, or 10 minutes, for 5 years, and then throw them away. The xfiles factor equals 0 means that there isn't a second copy of the metric on the live systems. That's why I told you we back up aggressively, but if you wanted more copies, you set it to 1, 2, 3, 4, 5, how many copies that you want. Using this, one metric will cost you about 3.3 megabytes of disk space. So you can very easily calculate out how many metrics you think you're going to be collecting and how much disk space you need. We think it's a fantastic trade-off between size and granularity. But you can go either which way that works for you. Next one, aggregations. Don't mind the small fonts, it's the bold bits that matter. Graphite has the option to do metric aggregations for you at the server side as the metrics come in. In effect, what they do is they generate another stat off the stat that you sent, and that will be written to disk dynamically. That means that you're going to be paying upfront for CPU and IOPS, but it's totally worth it if these are stats that you look at all the time, which we do. The graphs that I showed you were all aggregate stats. So I'm not asking you to go find my 100 nodes that produce this stat and then create the standard deviation or the upper or the whatever off of all these numbers. I tell it when they come in to already compute that. So graph serving is much faster. The first 2 lines compute a running average and sum. That's to avoid doing all that computation work. The second 2 lines compute the upper and lower bounds of a timer. So that's how we get the worst 95th and the worst 99th. We're letting Graphite do all that work. For gauges and counters, you probably want to do similar setups. We tend to dive in per host only if there's something that we feel that we need to dive deeper on, when something is obviously off. We feel that the aggregate stats should tell us the story already. That one dashboard should tell you basically how the service is behaving. And otherwise, we're doing our stats wrong. So these are all the good bits. Let's talk about some of the bad bits. The very first problem you're going to encounter when you scale Graphite is that you will run out of IOPS, guaranteed. So if you still have A-time on your disks, actually don't even raise your hand if you still have A-time on your disk. I'm just going to assume that none of you do. Turn it off. You really don't care to do a disk write every time that you go and look up a file, because you're going to be doing this all the time. Right? You're going to be writing every second. You're going to be generating lots of graphs. You're going to burn through a lot of IOPS doing this. But more importantly, if you can, get yourself some SSD machines. If there's one thing that is really worth splurging on a few extra SSDs for, it's this. The second problem is that the Graphite daemons are quite CPU hungry when they run at full throttle. Because it's written in Python, the daemons are single-threaded, and they could block on slow writers and slow readers. So you want to run multiple of each daemon type. So the faster the CPUs and the more you have, the more likely this will grow with you, even if some of the parts are slow. We run this inside of Amazon, which is special in its own way. And so we use high 1 4x large instances, which are basically the big SSD boxes with 2 terabytes of SSDs in them, to do all this stuff. We run 5 relays, 6 aggregators, and 6 caches. The relays to figure out which node should take care of it, the aggregators to do those rules I just showed you, and the caches that put them down. No, Don, I have 14 minutes. Well, you went over by 4. We still have 50% idle CPU, and we still have 40% free disk space, so that gets us pretty far. Alternative to hosting. If you are okay with hosting all your stuff, go with Circonus. It is absolutely the best in breed. You'll be very, very happy. If you want to self-host, Zabbix is the one that comes up most often. All of them have outputs for statsd and for statsd to go into here, so it'll be really easy, and those are linked from the right bottom. The real challenge, I should say, with these hosted systems is to keep the costs down, so I'll talk about that a little bit in a moment. For Graphite dashboards, there are many options. We like Graphite.js. It's a very thin jQuery library around Graphite that just helps you build the URLs. And so we host ours in flat HTML files in GitHub, and we push them as 3 when ready, and we have instant dashboards. The only thing that we really cared about was loops and variables. Because all of our systems look the same, I basically say for I in service, go build the graph. That's it. There are many more fancy ones, and I hear a lot of great things about Grafana. There's a guy who basically looked at every Graphite dashboard out there, and there are many. That's linked from the bottom right, and he does an in-depth analysis on all of them. So if you don't like this, there's probably like 20 more that you will like. Cost. So why bother with all this stuff? Why not just pay somebody money? Well, CloudWatch, we run on Amazon. Amazon offers CloudWatch, is 50 cents per metric. I'd be paying them $500,000 every month to do what I'm doing here, except it'll be 1-minute resolution on all the graphs. I like per second. And I can't create composite graphs. So those 6 metrics in a single graph, you can't do that. If you go with Circonus, which is really the best system out there, you're probably paying 30 cents a metric. You probably can get a bulk discount at this level, but still, it's kind of hard. Ours is less than $2,000 a month. So that's 0.002 or a fifth of $0.01 per metric. It's really hard to compare with that. And that's because Graphite does graphing, not alerting. Most of these systems do both. And because it's really hard to tell up front the difference between a metric that you will never want to alert on and a metric you might want to alert on in the future, they have no choice but to treat them all like alertable metrics. That's why their cost point is much higher. But you know the difference. If you do have some metrics you really want to alert on, you can mix and match. You can tell StatsD to send some of these statistics on to Circonus instead. If you're going to do that, use your user-facing metrics, pay them exactly for the stuff that you want to alert on, keep the rest in here. But most importantly, it aligns incentives. We want our developers and our operators to produce as many useful metrics as possible. We don't want anybody ever to say, gee, should I write down a metric here? I don't know. It's going to cost us 50 cents every month. That really adds up. I just want them to do it. So this makes it really easy to do so. All right. I also promise with minimal developer overhead. So adding stats to applications is extra work for developers, and you might not be able to motivate everybody to do so, or you have a bunch of legacy stuff that just nobody wants to touch because you might break things. That doesn't stop you from instrumenting the environment in which the code runs. And even though it won't give you insight in the specific part of the app that's not working, it'll still tell you that something's not working. And already that's very valuable. So I'm going to run through a few bits that we instrumented like that. First one, Apache. I feel pretty confident. Who knows what Apache is? There we go. Still a few stragglers. So we use Apache to serve all of our static content. That includes all those beacons that we use to capture the data analytics. Because there's no dynamic servers behind there, we can't instrument anything in a dynamic service, and therefore all the metrics have to come from Apache. So I wrote something called mod_statsd, which is the statsd interface inside of Apache. As part of the request, stats are now being sent. A link to the GitHub page is right down there. So how does that look? Basically, in the location header, you just say statsd on, and then you should probably specify a prefix so you can tell all your metrics apart. And so when then somebody goes to localhost API foo, you'll get apache.api.foo, Apache as the prefix, API foo as the path, then a get because that was the HTTP verb used, a 200 for the response code, and 31 for the time it took to respond. This is now done. Every request you get now does this. There is about 24 knobs and dials you can set on mod_statsd to do the aggregation and ignore certain parts and so on and so forth. So you can probably configure it to do the right thing for you for your Apaches. We care about performance. This thing is written in C. It adds less than 20 microseconds per call. So as long as that's within tolerable bounds for you, you should be fine. We serve about a couple of billion requests with this every day. So we're pretty sure it's stable, and I don't think it's leaking any memory. I say think. Who here uses Varnish? Excellent. That side of the room is way cooler than you guys. I just want you to know. So that's where we put all of our dynamic services. We capture from Varnish, at the very least, the backend used, the time it took to respond, and a response code. So again, for every service, even if it's not instrumented, we have that. For that, I wrote libvmod_statsd and libvmod_timers to get access to that information. It's the same as with mod_statsd. No matter how poor the service is, as part of the request, you get the data points. It adds less than 0.5% of CPU overhead, we found, and a handful of microseconds each request. This is roughly how you would configure it. The code you see is pseudocode because you need to pick up the variables throughout Varnish, unfortunately. But you basically send off a statsd timing event using the backend, whether it was a hit or a miss, and the response code, and then the time it took. And then the naming scheme that you're going to get is exactly the same as mod_statsd because I like consistency. The documentation, again, on the full right, again, it has a whole bunch of knobs and dials that you can use to configure this for you. OK, that takes care of all of your web requests. And if you remember this sample graph from earlier, there is no service instrumentation here. This all comes directly from Varnish. So even if this were a service that had no metrics of its own, I could still get this. Python, right. One of the best things that you could possibly do is to instrument your infrastructure is to provide a base library that includes statistics, logging, and argument parsing. And ideally for all the languages that your company uses. We use a lot of Java and Python, and we open sourced our Python one, so I wanted to share that one with you, but there's nothing stopping you from implementing something like this for all of your stuff. So this is our Python one. Our main design goal was to make it really easier for developers to do the right thing. If you inherit from the Krux application class, you get all the tools and instrumentation you need to build a good CLI app. And we also have a Krux Tornado app to build a good Tornado dynamic service. Same idea. We make some really opinionated choices about stats, but we think it's a really good pattern to follow. It's essentially all the patterns I've been showing you so far. And this makes it really easy for developers to have stats instrumentation in their code without having to worry about anything. They just have to provide a name for their app. Right. So the installation instructions are right there, and the documentation is linked from the right corner. And I'll be on SlideShare, of course. So how would that look? Even the basic app comes with this stuff. It'll have a log level, and it has stats stuff in it. This is good for us operators, because even before the first line of code is written, that means that we, the operators, who are about to deploy this using, I'm assuming Puppet. Any Chef users here? I don't think so. 3 minutes. Oh. It's really easy to add the dash dash stats argument and the dash dash logging equals warning, and we just get stats and we get warning logs on our systems. Developers don't have to think about anything. So it helps them do the right thing without any extra work required on their behalf. And this is just standard inheritance stuff. You just say, my application inherits from Krux application, and then you get a stats object, you get a logger object, and it all just works. And again, because the only thing that they have to provide is a name, that sets up the identification in stats, it sets up the identification in logs. We provide the stats and the logging argument, and we win. Just about all of our legacy apps, and definitely all of our new applications, are built on top of this, so we know it works pretty well. In the worst case, if you can't write a nice base library, your tools probably are able to do this. A simple netcat command line tool or send off a UDP packet. This is at the end of every Jenkins deploy that we have. So there are all the Jenkins build steps in CI. When it's green and it's ready to deploy, it just sends off echo events.deploy.name of the app to the localhost statsd. And now I know that that app got deployed by Jenkins, and that's that brown vertical line I showed you earlier. And that works for just about anything except, of course, JavaScript. And for that reason, we wrote a separate stats app. Unfortunately, not yet open source. I would have added it here, which takes the stats on HTTP and converts them to a statsd call, which means that you could do an async JavaScript call and instrument your stats directly from your web page as well, without users noticing any type of latency. Given that this is a Puppet camp, I should probably mention the word Puppet. It doesn't have to be code that you wrote that you instrument this way. Puppet produces tons of really good reports. They tend to end up in log files, or they tend to end up in local reports. But we wrote a report plugin, which is, again, linked from the bottom, that will take that report and sends them off as statsd stats. So then you know like how long your Puppet runs took, which execs had errors, and all that kind of stuff. So you can graph that as well and see whether your nodes are starting to behave differently. Again, the documentation is on the bottom right. And lastly, who here runs inside of Amazon? Okay, this is important for you guys, especially if you're cost conscious. CloudWatch has a command line tool, which is basically this, and you can ask it for how much money you've spent so far this month. So we have a little cron job every 15 minutes that loops through the services that we use, say MapReduce, EC2, S3, and we just get the dollar amount of how much we spent. And we send that off to statsd. So we have a little graph for every month that goes like, on the first of the month, we spent no money, and then we spent this much on all of our services. And we overlay that, and so we know whether we're spending less or more. See, I'm 2 minutes early on my slides. All right, so the next person can come set up. Thank you for listening. If you have any questions, I'll be here while the next person sets up their laptop. Anyone? Oh, thank you, thank you, thank you. Any questions? Sir? How do we do alerting? That's a fantastic question. We have that collectD plugin send our things to PagerDuty. And we have 3 nodes, one in every data center that does what we call middle tier checks, because these would be alerts from every node. Alerts from every node go to a warning dashboard that doesn't page us, and these alerts from these 3 special nodes are a higher level overview. Let's say that there's not enough capacity in our load balancers, then that would alert. You're welcome. Do you need mine? Okay. Any other questions? All right, well, thanks again.